today's quantum computers, whilst they're still in some cases able to perform calculations that demonstrate quantum supremacy, I think the challenges that they're solving, because of the maturity of the field, they're still not the kind of challenges that we need them to solve.
My name is Yarema Reshitnyk. I work at Oxford Instruments as a senior cryogenic engineer.
My name's Poole. I'm a senior development engineer at Oxford Instruments NanoScience, and I work in our new product introduction team.
In my undergrad, I started doing low temperature physics experiments, which kind of gets you into more of an experimental background. I actually started as a research assistant in this new lab that was forming there, and I did that for about 6 months and then decided to stay there and do a PhD in that lab.
I first started at Oxford Instruments a few years ago working at plasma technology. I originally moved into the semiconductor industry after completing a PhD studying properties of graphene. Whilst I was working there, I got the opportunity to do a secondment to the nanoscience business to work on ultra-low temperature systems. Looking to try something new, I moved in and I haven't looked back since then.
The superconducting quantum community requires low temperature environments to run their CPUs essentially with. They call them QPUs just because it's quantum. So they need that low temperature environment, and essentially what Oxford Instruments does is provide them with the space and cooling powers required. So an environmental platform really for them to enable doing what they need to do. So right now we're one of the big providers in these environments and platforms for these companies to use.
We're quite lucky in that we partner closely with different universities. We're talking to small startup companies and able to provide, whether that's an etch or a depth plasma tool or a dilution refrigerator, to those companies. As the commercialization of quantum technologies continues to pick up pace, we start to see a shift more and more to industrial customers. And so for that reason, not only do we have a strong manufacturing centre in the UK, but we also maintain a global footprint as more and more customers around the world and more organisations around the world are developing some sort of quantum computing programme. Oxford Instruments seeks to address that by having technical support throughout all the key territories. One of the challenges for quantum computing in general, and not just looking at superconducting qubits, is that it's still a technology that's prone to errors, which limits its ability to perform significant computation. So we're in an era now, or approaching an area known as the noisy intermediate scale quantum computing industry. And during that period, for every logical qubit that you need, you often need several physical ones. In terms of what that means for engineering, if it's a dilution refrigerator, it means we have to understand more about the cooling powers we need to apply to the system, how we can provide those in a cost-effective way and a sustainable way that also accommodates the upgrade pathway of our customers, but also a design that we can manufacture, assemble, test within our factory and then support for the next 10 years. The refrigerators that we're designing are a significant investment for a lot of companies, and we'd like them to make the most of that investment with Oxford Instruments. Today's quantum computers, whilst they're still in some cases able to perform calculations that demonstrate quantum supremacy, I think the challenges that they're solving are, because of the maturity of the field, they're still not the kind of challenges that we need them to solve. I'm sure that will come eventually, but that's really where the interest is for me, seeing how quickly we can get on to solving some of the more difficult problems.
I'm assuming at some point in the future these quantum companies will be able to improve some of the miniaturizing of components and multiplexing of lines and these sorts of things that'll reduce the amount of space required for these things, and then it'll probably push us into a different regime of more cooling power is required for at different stages. And so it's kind of right now it's growing physically in size, future probably growing in specific cooling powers for the market. There's always new challenges, sometimes new fires to fight, but it's keeps you wanting to come back.